Alright, hello everybody. First day of our new unit. So we are looking at what is called sum and difference identities. Now, the issue here is if you look at this first problem, so cos of 75. We've always been focusing on our unit circle. And with our unit circle, our primary focus, if we do 3, 2, 1, 3, 2, 1, over 2, over 2. Now let me just put this unit circle here. Alright, so there, 30, 45, 60. Alright, so when we've been doing this work, we've been doing unit circle pieces, and with these unit circles, we've always done things that relate to 30, 45, and 60. Well, here we're looking at cos 75. Alright, so cos 75 is not on our unit circle. Well, it's there, but it's not a nice clean point. So we can actually use these formulas to help us solve for cos 75 by using angles that we know from our unit circle. Right, so if I'm looking at cos 75, and I'm working with 45 and 30, that means I'm looking at the cos addition formula. So what I have here is cos of 75 equals cos of 45 plus 30. Right, using my formula, cos of 45, cos of 30, minus sine 45, sine 30. So I laid it out entirely with 45s and 30s. And now once I have this, I can jump to my unit circle. Cos 45 is rad 2 over 2. Cos 30 is rad 3 over 2 minus rad 2 over 2 times 1/2, which gives us rad 6 over 4 minus rad 2 over 4 for rad 6 minus rad 2 over 4. Right, so that's not going to come up on our unit circle, right? But by using 45 and 30, which are on our unit circle, we could solve for cos 75. Right, so if we change it up for a second, right, instead of using the addition formula, let's say we have the subtraction formula, which would be cos of 45 minus 30. Right, so we expand with the formula, cos 45, cos 30 minus sine 45, sine 30, which gives us rad 2 over 2, rad 3 over 2 minus rad 2 over 2, 1/2. And we get, oh, my bad, wrong formula, plus. Always throws me off that the minus actually has the plus in it. Rad 6 plus rad 2 over 4. And here, and here's one of the common things with these problems. The fact that we are constantly using, we're constantly using rad 3 over 2 1/2 and rad 2 over 2, our answers are going to be really similar. There's going to be a lot of things in these problems where you have rad 6, rad 2, and a common denominator of 4. So if we look at the next one, right, so we got sine of negative 75. And being honest, is this the only way to do it, by adding? No, all right, we could set this up different ways, but I'm trying to just structure it so you can all work in the same setup now. All right, but as we get going, I want you to try this out whatever way you want. All right, so here we have sine 45, negative 45 plus sine of negative 30. So we have sine negative 45 cos negative 30 plus cos of negative 45 sine of negative 30. All right, so key thing here, ASTC, those negative angles put us in the fourth quadrant. All right, so sine of negative 45 is not rad 2 over 2, now it's negative rad 2 over 2. While cos of negative 30 is positive rad 3 over 2 still. All right, plus, all right, I got another negative here. Oh, my bad, nope. Cos is positive in that quadrant. Right, so I got rad 2 over 2, while sine of negative 30 in this situation would be negative. As we work this through, we get negative rad 6 minus rad 2 over 4. And like I said, the same things over and over and over and over and over again. I'm not going to show the work for the last one, but the last one's going to be rad 6 minus rad 2 over 4. Same thing, over and over and over and over again. All right, so if we move ahead for a second, all right, here's some practice examples. You'll check with the answer key. All right, now we go down here. So this is what we're working towards, being able to do this without being told what to do. All right, so if I look here, if we're using sum, cos of negative 60 plus negative 60, that works. All right, so I'm going to do this two ways to just prove a point. All right, so this would give me, in this situation, cos negative 60 minus sine of negative 60 sine of negative 60. So we got ASTC, right? Negative 120 puts us in the third quadrant there. Negative 120, yeah. Okay, so what do we got there? All right, we got the point of 1/2 negative 3 over 2. That does, hold on one second. Negative 120 degrees puts us third quadrant plus 360. All right, so we got the point of negative 1/2 negative rad 3 over 2. All right, so cos, we got negative 1/2 negative 1/2, all right, minus negative rad 3 over 2 negative rad 3 over 2, which gives us here 1/4 minus rad 9 over 4, which gives us, in this case, 1/4 minus 3 over 4 for negative 1/2. And with the work that we have, I wouldn't expect you to do the sum formula for this, because we can actually just use our unit circle to find negative 120. Right? But showing this again, right? So if we go cos, in this case, of negative 90 plus negative 30. All right, so here I have cos negative 90, cos negative 30, minus sine negative 90, cos negative 30. All right, so we got the point, if we're talking negative 90 degrees, we got 0, negative 1, negative 30 degrees. Oh, that's why I messed up before. My bad. We're talking about negative 60 degrees, so we're in this quadrant. Okay, one second. I knew I made a little error. I was focused on the wrong spot. Okay, same answer, just a slight error. All right, so I got negative 1, and for negative 30 degrees, I got negative rad 3 over 2, comma 1/2. I'm messing things up left and right. Positive rad 3 over 2, negative 1/2. All right, so here I have 0 times, technically doesn't even matter, but rad 3 over 2 minus negative 1 times, oops, that should be sine. Yikes. Once I'm committed to the video, I can't go back. Sine would be negative 1/2. All right, so here we get 0 minus 1/2 for negative 1/2. All right, so there's multiple ways to do the sum formula. You could have done the subtraction formula, it doesn't matter, right? As I said earlier, you didn't even have to use these formulas, because you could find cos of negative 120 just by using your unit circle. I'm presenting all these different ideas to you. All right, tan formula. All right, key thing about tan. All right, tan, we got 30 degrees, 45 degrees, 60 degrees. So if we're looking at tan, y over x, if we do some simplifying, rad 3 over 3, 1, and rad 3. That's what we have in these situations. And, have that somewhere, know that it's useful. So with our tan formula, right, we have tan 75 equals tan 45 plus 30. All right, so which one do we got? The addition problem. So tan 45 plus tan 30 over 1 minus tan 45 tan 30, which gives us 1 plus rad 3 over 3, 1 minus 1 times rad 3 over 3. So 1 plus rad 3 over 3, 1 minus rad 3 over 3. We got to simplify this a little bit. And one thing we've learned is that to simplify, if we put everything over the common denominator, we can then drop our denominators. So 1 is 3 over 3. Which now that I can drop my denominators, I got 3 plus rad 3 over 3 minus rad 3. All right, next issue. Can't have rad in our denominator. 3 plus rad 3 over 3 plus rad 3. All right, so we do some foiling. 9 plus 3 rad 3 plus 3 rad 3 plus 6 rad 3 plus rad 9, which is 3, over 9 minus 3, which is 6. 12 plus 6 rad 3 over 6, which gives us 2 plus rad 3. Answer. And with all these problems, right, constantly, right, these problems will constantly have the same answer, the 2 plus rad 3. Right, so here we got, this one's going to be 2 minus rad 3. This one's going to be negative 2 plus rad 3. This last one's going to be 2 plus rad 3. Same exact answers over and over and over and over and over again. And if we look at example 2 down here is the same as the problem we just did. But instead of using 45 and 30, you're using 120 and 45, and you're using the subtraction formula. Right? Same idea, same answer. So if we look here, this would give us tan 120 minus 45, which would be tan of 120 minus tan 45 over 1 plus tan 120 tan 45. So here I got negative rad 3, because based on ASTC I'm in the second quadrant, minus 1 over 1 plus negative rad 3 times positive 1. So I got negative rad 3 minus 1 over negative rad 3 plus 1. All right, conjugate time. Multiply by negative rad 3 minus 1, negative rad 3 minus 1. Go through the foiling idea. Here I'm going to get 3 minus, minus. Right, so 3 plus rad 3 plus rad 3 plus 1 over 3 minus 1. And so I got 4 plus 2 rad 3 over 2, which simplifies back to that. So again, it's the same answers over and over and over again. With the tan problems, you're always going to have to use the conjugate. With the tan problems, we look up here, like problem A, you're going to have to do that common denominator for everything idea to get it going. So as you work through, like the problems we look at here, 3 and 4, you're given some options. Problem 5, you want to create your own idea. So know what? I'm going to go with tan of negative 60 plus negative 60. All right, so that's going to set me up as tan negative 60 plus tan negative 60 over 1 minus tan negative 60 tan negative 60. All right, so that gives me negative rad 3 plus negative rad 3 over 1 minus negative rad 3 times negative rad 3. All right, so I got in this situation negative 2 rad 3 over 1 minus 3 for negative 2 for rad 3. Which again makes sense because we don't have to use the unit circle for this. If I add 360, I got tan of 240. All right, so my reference angle here, 240 minus 180 equals 60 degrees. All right, so I'm in the third quadrant. All right, so reference angle, third quadrant, rad 3. Done. All right, so try these out. Give it your all. There's a small homework assignment to do. Hope you can get that done in class. And when I see you next class, we'll knock this all out and make sure we're okay.